certification, and I'm going to get into a little more detail on this process. So any project over 10 acre-feet or greater requires an irrigation certificate, and the way this is sort of enforced is you need your water rights license from Water Security Agency, and they require that irrigation certificate before they'll give you a water rights license. And for that water rights license, you need 12 acre inches of water for the area of your project. And it works a little bit differently in the district, where the district holds the water rights license, but you give your irrigation certificate to the district, and they give you a water service agreement. So why do irrigation projects need to be certified? This is mainly based around resource protection and environmental sustainability. So we want to keep our waterways healthy, as well as the irrigation land, and protecting your investment in your irrigation infrastructure. And then we also want efficient and effective use of water. So there's a lot of people that use the water in the province, and if someone's using that for economic purposes, we want to make sure that we're providing long-term productivity on that land. So maintaining that soil health, not waterlogging the soil, that kind of thing. And then on top of irrigation certification, we'll provide development recommendations. So that can be drainage. Sometimes it's a drainage requirement for surface drainage, but we'll recommend that you might want to do tile drainage in certain areas, and that's usually fairly formal in the certification process. But other times, irrigators or potential irrigators will have a bunch of parcels, and they don't really know how to start looking into irrigating and what parcels would be best to develop. So they'll come to us for that kind of advice, as well as agronomic advice. And where it all starts is a request for technical assistance. Stan kind of talked about this, but this is your first step into getting your irrigation certificate and getting in the process. And there is a check mark box there for your soils. I know sometimes they'll sort of do the preliminary engineering first on Randy's side of things, and then do the irrigation certificate if that goes well. But other times it's fairly obvious that the project has good potential, so they'll just go straight for soils. And then when we get files on our desk, before we go and do our soils investigations, we'll do a bit of a preliminary investigation, which is just looking at soil survey. So this is one development that we were working on, where we looked at the soil survey. It's loam soil, defined sandy loam, which is really good for irrigation, but it has some large depressions, sloughs on the field. So we know that there's potentially some requirement for drainage here, but we're really not too sure until we actually get out there. And in this field, when it's dry, those sloughs shrink, and when it's wet, they really grow in size. So we know that there's probably going to be some requirement for drainage here. And in this case, that producer kind of already knew that and wanted to do that. Excuse me. And so when the technicians go out and do their preliminary investigation, they'll grab us a water sample to sort of see what the water's like. It's one of the most crucial parts of the project. So if it's out of Diefenbaker, we really don't have any problems. We don't grab a water sample, obviously. But other areas, we'll get a water sample and we'll send it off to the lab, and they'll give us a bunch of data on the salts in that water. Mainly what we're looking at is the conductivity and the SAR. So the conductivity is a a basic indicator of how much salt is in that water, and the SAR is a indication of how much the ratio of sodium in that water. So we don't want too much sodium. And this is a really good water sample at 900 microsiemens per centimeter of conductivity. And then this is a bad, or not a bad, more marginal sample. Still potentially good water depending on the soil at 2,000 microsiemens per centimeter. So that first sample, I just put a dot on this indicator diagram that we use. So that sample is pretty much good for any soil type. And we actually have a limit in our in the regulations to be eligible for CAP funding, which is set at 1.5 millisiemens per centimeter. So if you're over that, if your water source is over that value, then you're not eligible for CAP, but there is still potential that we could approve that project based on the soil. So that other water sample, we really want to see a loam on that soil, and not too much groundwater influence or anything like that. So we go out and do our soils investigation. This is a bit of the history of our EM38 survey. So we'll go out with the EM38 and drive it through the field, collect a bunch of data points on the field. And this EM38, it measures parent soil electrical conductivity of the soil, and the values off this instrument are influenced by soil salinity, soil texture, and soil moisture. So, but this device gives you it's very sensitive to soil salinity, so it's very good for measuring variability in soil salinity. And there's that instrument there. It's actually, there's two of them stacked on each other. There's a horizontal and a vertical. And the horizontal gives you the highest relative response at the surface, and then the vertical gives you a higher response at about 1.4 meters. So you can get an idea of where the salts are in the soil profile, which can tell us things about groundwater and the sources of salinity and causes of it. And when we're out there, we'll take soil texture, or we'll gather information about the soil characteristics. Mainly texture is our most important thing we're looking at, because that is an indicator of water holding capacity, infiltration rate of that soil, as well as drainage issues. And geologic unconformity is also pretty important, which is pretty much different soil layers on top of one another. And then depth to drainage is pretty much if we're coring down to 3 feet and we're finding soaking wet soil, we know that there's some groundwater issues there. Okay, this I'm going to move into to just talk about some soil-water interactions, because this is a lot of what we'll be talking about a bit today with irrigation scheduling. So on the right here, or we just have an image of the soil, which is like very zoomed in. These are soil particles, and on the right, a permanent wilting point. The moisture is in very small pores, and the plants cannot access it. In the middle, this is a gravity, like a soil filled to capacity and gravity drained. So the soil is in larger pores, and it's very accessible to plants. And where we get into issues, if we go over field capacity and saturate the soil, then that soil can no longer hold on to the water. So then it drains by gravity and ends up in your depressions. And the types of soil textures play into this a lot, where sandy soils, which would have a lot of the blue circles, have very large pores, cannot hold much water, and drain very easily. Where if you have a good mixture like that with sand and clay mixed in a loam, there's very good soils for irrigation because they hold a lot of water and they drain quite well. So more on this so that number one on the left there is a situation where you fill your soil past field capacity into saturation, and then the water flows through the soil column and ends up in your depressions. So that's a case where you're irrigating with too much volume. And then that number two over there on the left is where you irrigate past your irrigation rate. So that's where you get overland flow and surface runoff, and the same scenario where you have pooling in your depressions. And the other side of this figure here is, Kelly will get a bit more into this in the next presentation, but when you get these saturated areas, you have problems with salinity around them. And because the plants around those areas use the moisture, the soil draws up more moisture from that groundwater, and the salts concentrate at the surface. And this also happens if your groundwater level is too close to the soil surface. So back to our investigation, we'll collect 1 foot increment soil samples down to 4 feet. We will get the soil texture of these samples, as well as send these samples away for salinity analysis. And this is of that field I showed you earlier, where we sort of have fine sandy loams on the upper elevations and some clay loams in the depressions, and a bit of salinity around. I'll get into that. And then we do a regression with our EM38 data and the actual EC measurement from the soil samples. And we have all these points where we drove that EM38 across the field, and we interpolate that into the finished product, which is the soil salinity map. So in this field here, we have these are the depressions that were in that field. So in those locations, there's downward movement of water, which leaches the salts out, so you don't have salinity there. And note that when we sampled this, there was no standing water in the field. And then around those depressions, we get that evaporative salt ring. So with this project, we required that he do surface drainage. And I think he maybe ended up doing tile anyways, which was probably about like just within those depressions. And this is the Agro environmental report that you get with that through the certification process. And this is just telling you all the sort of important key points about irrigating this land. So this is a bit of a messy document, and there's a lot going on, and we're in the process of changing it right now, but on the top there, that first dot, we have this data on the soil sample, and I'll just point out the key things. So we have the water sample here, looks good. Right here we'll have the soil texture. I doubt you can see this, it's a little blurry, but we'll have the infiltration rate of that soil, give you an indication of how much water you can be applying at a time. Here we have whether it's recommended or not, and this project was recommended with soil precautions. Most projects are recommended with soil precautions, sometimes water if it's a marginal water source. And then I pretty much said if you irrigate the upper level positions too much, you're going to get runoff into those depressions, so you need to drain them before you can. The drainage is a requirement of the irrigation certificate, and then I also made a note that you might not want to grow salinity sensitive crops until that salinity issue is sorted out. which the irrigation with the drainage should sort out that issue. And then we have the irrigation certificate that comes with the Agro environmental report. And this is the legal document that goes with, that's your irrigation certificate that you send off to Water Security Agency or your irrigation district. And with all that, and then after we're done, it goes to the engineering side. They write up a preliminary plan. I'm not really gonna get into that. I think Stan did quite a bit on that. And then hopefully you can be irrigating. Yeah, so are there any questions? Yeah. Okay.
Questions?